Hello, my name is Connor Weaver, and I will be going over toxic shock syndrome. Toxic shock syndrome is actually caused by toxin-causing bacteria such as Staphylococcus aureus and Streptococcus pyogenes, and these bacteria actually produce super antigens, which actually do lead to the actual cause of toxic shock syndrome. But I'll go more over that in the next slide. Um, They are characterized by uh, uh, toxic shock syndrome is characterized by having a fever, hypotension, uh, sunburn like rash, and organ failures, vomiting, diarrhea, things like that. Um, so the mortality rate for Staphylococcus toxic shock syndrome is about 5%, whereas it's between 14 and 64% for those with Streptococcus toxic shock syndrome. As I said before, the super antigens are actually created from they're actually produced from the bacteria themselves, and so I have here in the top, this is the normal T cell activation, and then I have in the bottom, I have the super antigen T cell activation. So I'll start with the normal. Um, in normal, you have your MHC class 2, um, and you have your antigen within it, and it has to fit in this peptide groove, this perfect peptide groove, almost like sticking a key into a lock. It has to fit it perfectly. If it does not fit, it won't bind. Um, so with the super antigens, um, they actually can bypass this and by so what they do is they bind the MHC class 2 complex to the TCR, but they do this on the outside of the peptide binding groove. And what they do is they bind to the the beta chain of the T cell receptor in the variable region, and by doing this, they don't have to abide by the rule of fitting into that perfect peptide binding groove. So essentially, they can bind to many different types of T cell receptors, and so what happens is um, the super antigens activate about 25% of the T cell population. And what happens is this leads to an overproduction of pro-inflammatory cytokines, and that's where I'm going with the next slide. So with the overproduction of the pro-inflammatory cytokines, this is what we call a cytokine storm. This is what leads to TS, and I wanted to go over some of the cytokines as they actually play a role in some of the symptoms that you see, such as IL-1 and TNF alpha. They are characterized by the fever. Um, TNF alpha, especially, is actually when it's overproduced, this is what results in the toxic shock. Is caused by edema and intravascular volume depletion, which leads to hypertension, shock, and or organ failure. So there is no one test for toxic shock syndrome. It's a mix of diagnosing symptoms, doing like blood test analysis. Yep. So in our case study, a 16-year-old girl who was a normal 16-year-old healthy girl, um, she had a fever one day, And then she started to get progressively worse. She started having abdominal pain. She got nauseous and threw up. And so her mother took her to the hospital, and when they got there, they noticed that she had a rash on her, and so they ran some lab tests, and they found that her white blood cell count was extremely high. They found that her blood coagulation time was prolonged, which indicates liver damage. Um, they'd also found that her blood pressure had significantly dropped as well, and so did her blood volume. Um, and so what was interesting is they did a cerebral spinal fluid culture and blood culture, and those both came back negative. But then they did a vaginal culture, and that's when they found Staphylococcus aureus. And she admitted, and when they questioned her, she admitted that she had put in a tampon earlier that day. But usually it takes about 12 hours for one to develop Staphylococcus aureus and to develop toxic shock syndrome from having it in um, usually around 12 hours, past 12 hours, but she only had it in for 6. So her cause of staph is still not known. She was treated with antibiotics, given an IV for fluid, and she was given intravenous immunoglobulin. So some of the long-term effects of toxic shock syndrome. Um, so there's not that many studies about toxic shock syndrome long-term effects after you've received it. We do know that those who have had it usually don't develop TSST1 antibodies, so they are susceptible to get it again and can get it again if it happens again. Um, but this study looked at how it affected their health afterwards, and what they had found was is that those who had suffered from toxic shock syndrome afterwards, they were more likely to be hospitalized for renal issues, liver issues, and cardiovascular issues, which makes sense because that's usually the organs that are affected during toxic shock syndrome. And what was interesting is they actually found that males that have suffered from toxic TSS are actually more likely to be hospitalized again than females are. Um, uh, and this was one of very, 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 very few studies about this topic about long-term effects. I believe that more studies should be performed in the future to understand the long-term effects. So for question number one, regular and like conventional antigens cannot produce um, cannot activate naive T cells, whereas super antigens can. But the bigger difference is normal antigens have to uh, go in to bind the MHC complex to bind the MHC to the T cell receptor. They actually have to go fit directly in. They have to fit the peptide directly into the peptide binding groove. Again, the analogy for that is a key in a lock. It's got to be a specific lock and a specific key to get into that lock. Whereas the super antigens obviously can bypass this by binding the MHC class 2 to the GCR receptor through the super antigens binding to the beta chain in the variable region of the T cell receptor. Number two, so with a conventional antigen, they have to kind of be processed, internalized, and it takes some time. There's a lot of different steps for it to go through, and that's because it's I believe it's about 1/10,000 fits into the specific its specific peptide groove. And with the super antigen, again, they can skip all these steps because they can just bypass that and just bind right to the right on the outside of the the variable region of the beta chain. Sorry. Um. So for number three, um, the T cell activation results in the upregulation of the natural ligand of for FAS, FAL, um, which causes apoptosis of uh, the liver cells. For number four, yes, she is, and this is because people that have had toxic shock syndrome, um, usually through it's the through the super antigen TSS T1, and because of this, they can't develop antibodies for TSS T1. And that is it. Thank you.